case, and this use case is regarding the practical NLP application. So what happened is that, let's say like that, we have big database of text and we want to categorize the type of text. So for example, we want to actually get different news automatically scroll from the web, and then we want to attach some label to it. So this is a very normal use case what happened in the industrial setting. Sometimes you encounter such a problem that, well, you need to categorize a big databases of text so that you can further process it. Let's say like that you need to categorize the news. So for example, you have developed some crawler to crawl the news. Now, not every news is relevant to you. Let's say you're working in the health care sector, and you only want to extract, or you only want to see those news which is related to, let's say like that, policy making, or any authorities change the health policies or something like that, or any for example, any news which is regarding to the endemics, pandemics, corona, or any contagious disease and something like that. Now it's the filtration is very necessary and very important as well to build a further use case. But let's discuss this use case first. So normally, what is the starting point? Like starting point of this use case would be that we want to collect data, or we want to build a crawler. So for example, crawler actually crawl up multiple texts and send us a JSON response. Sends us JSON response back. So what the JSON response is that you have a dictionary where you have key, and then you have value, and then you have key 2, key 1, value 1. And for example, sometimes you have key, but key needs a multiple value in there. Then you have a key subtype 1, value subtype 1. So this is normally a structure. Let me just show you practically data which we have taken in for this use case. So for example, this is the data which tells us you about something, which gives you a lot of other information when it is extracted, what was the text of the data, and blah, blah, blah. And in this case, for example, we were able to collect multiple text in the one domain. For example, it is about the health policy news, any policy change, and second is, for example, any information or news related to disease itself. And we have stored this data somehow, pre-processed data already stored in your databases. Now we want to already build the crawler on sub-process data, or already pre-processed data, or somewhat pre-processed data, which actually gives us some structure of data already. But now we want to really segregate each text further on. So let us now develop a complete two classes for that. So I have already built it, and I'm going to show you code by code, line by line, that how it does and what I have done here. So let me just walk through. Okie dokie, here we have complete small class. Let us first load the data. For example, we need to load the data. We have created this preprocessing class. We have defined the initialization. What does initialization means? That whatever you run here, it's automatically executes regardless if you execute that function or not. This is a basic principle of class-based or OOPS-based structure of any Python code. First we covered this, and we'll come back to this code again. Which means the data loading means that we have JSON data. Here you can say we have JSON file. What we have written is a simple file path, self.file path, and our main reading encoding means UTF, like this is the encoding standards of different languages character as a f, and data JSON.loadf. JSON is the library which we have imported above, and now return the data. What it does, It returns us complete string by string data back. And now, for example, we don't need all data. We are only, for example, we are interested in the description of the text. And when we see the text, we need that there is some full text or source or some information available. So what we can do now is that we create another function where we pass on the raw data to the system. And what that does is that it's hit means that there are two keywords which is encapsulated inside. For example, if I just go here, and you can say this is hit and then hit, and under the hit there is full text, right? There is source, and then we can reach up to there. So very simple. We actually have given a simple numpy array slicing technique where we our dictionary select key selection, where we written hit and then hit. Then actually we have created a small empty list, and then we loop through for article. In the article ID is equal to ID. Well, because we need that. Full text is always like source and full text, but we have seen here that it is under the full text after that. So kind of we are navigating from hit ID source full text. That's how it's written here. And when you found this key, we want to resultantly upload or append from the simple list appending method. But we append the article ID and full text and self dot label. What is the label actually? Because the data is semi pre-processed, which means that first we crawl the data and we already attach some label, meaningful. We have categorized them into two or like X categories. And because we need to kind of label data to train our model, so that every new text crawled, it automatically sort out or give the label to that article or that text. For that, we already need to identify label. What we have done, we haven't. So, for example, we have simple Excel sheet. In this Excel sheet, for example, we have two columns. We have, for example, we have actually created simple Excel sheet where we have labeled the data, like we have t text here, for example, and then we have categorized the text into one whatever category it is. So, for example, it is healthcare H, then it is policy making P, and then this is disease related text D, and whatever category. So this is actually get category, and this is text itself, and we have completely made the file of different categories in different ways, so that right now we are actually dealing with two categories, because we have a lot of large text categorized or encapsulated in two databases. For example, file 1 and file 2, all the text which is related to the policy making goes to file 1, and all the text which is related to disease goes to class 2, which is, for example, disease. And then we know actually that we have this label. So when we read all the text related to label 1, we can give it label, and then so on and so forth, right? So we're gonna do this actually two times. We are going to run this file two times, right? This is that, and then the next function is actually creating the data frame. So pandas data frames are a good way to, let's say like that, very good way to work together. It gives a lot of functionality like concat. You can see that we have two databases here. Now we are able to get the label of them and concatenation of them and return us one single database. So then we have final pre-processing with respect to NLP. And what NLP does it is tokenize each text into the part of speeches, so it is noun, pronoun, verb, adjective, or preposition, whatever. And then you need to always remove the word which don't carry much meaning with respect to model training. For example, the, I add, in, or, comma, semicolon. These information are really not much meaningful for the natural language processing. So it's a kind of limitize. Limitize means that you remove all this stuff. So it takes all the token from the dog, and if token is not stop word means that there is already negative list of word in the database of species. This is in natural language processing library, which gives you a lot of tool nowadays. You don't need to reinvent the wheel, but you must have only knowledge of the tool already available. You can use them, so there is no needing to reinvent any wheel. Which means that we have a dictionary of stop word. We can just filter through all this. That if there is no stop word, and if these are alphanumeric, or for example alphabets, in that no number and stuff, and then just give us pre-processed text and join them again. Join them again means that join them in the dictionary fashion again, so which gives us a pre-processed text. Cool. Let us see that here in the classifier setting. So for example, I'm giving two file here to my function, right? And then what I'm doing is that from pre-processing, I'm importing the function pre-process, last pre-process, which is here. So normally you similarly do this in the Python, right, as a pp, and then I just pp give to the pp I give the file paths, which are, you can see here, the file path is the parameter or argument needed for that. Label you can give, I have given this label this, and second one label that. So later on I can really let's say like that, assign any human readable label. I can also assign 0 1 here, but just I have taken the last word from the file name, and it's okay. So then with the same class we have written another function, and this is the beauty that we always can call any object within the class. This object in uppercase is join data frames. So what I'm doing is that for example, d file 1 and d file 2 is two classes I have initiated, and then I am just using any single one because they are belonging to same preprocessing class. And preprocessing class dot model, like dot method, whatever I have written. Dot method means that the method is create data frame here. I can call it, and then I can give it two files, and it gives us beautiful 522 paragraphs with 3 dimension, because we have written text ID as well. So great. So we were able to do that. Now for example, let us pre-process text, join these two things, and then let us apply a function which we have written here as a name of pre-process, because if for any single text we need to pre-process it, because we need to tokenize it first as a dog, and then we need tokenize mean that if null, that vectorize. So we need to do this somehow, and what we are doing, we are just this is again the beauty of the pandas, that even if there is some relevant data written in the pandas, in the column format, what you can do is that for example, you want to apply some calculation on any row, like a row maybe has 3000 values, 1 to 3000 values for any column, and you want to apply something. You don't need to apply like one function to whole bunch of rows. You can just use dot apply, and there you can apply whatever, any function in the world. available in the world of Python. So the similar we are doing, we are getting the full text from the database. This is the pandas database, some are very relevant working with the dictionaries in the Python, like dictionaries and value key pairs. And we can also call any key. For example, we are calling a key full text, which is making the full text available beautifully, and then we can apply. And as you can see that here is the pre-processed text, which kind of now give us the class, which class it belongs to, what is the article, what is the full text, and then pre-process is kind of where it's lemmatized stuff and remove some of the items from it. Great, that was the story of pre-processing. Now we get the data. So for example, you have now 3000 classes of anything. Like for example, you want to categorize the news text into the 10 major categories. So it is belong to sports, it's belong to stock market, it belongs to healthcare, it belongs to like 10 main 20 classes, whatever classes. Here is the data pre-processing you need. You need any ID, it's optional, then text, and then you can add classes here, like class 0, 1, 2, 3 up to n classes, and you need to then pre-process that class. So that is the primary structure of the data right now we get, where in the one column we have class label, and in the second column we have pre-processed text with respect to NLP. And until and unless we have this data structure available, we can apply any natural language pre-processing or post-processing or analysis technique on this kind of model. And that is where actually from basic NLP up to transformer and ChatGPT really get involved. So this is just a matter of them applying a model. And in further tutorial, we are gonna apply some state of art model, plus we are going to build some private GTP without involving any API from the OpenAI. So for the data protection stuff, we can build our local kind of chat GPT, plus we can also sometime create a organizational knowledge context, which means that only reply my query with respect to all knowledge in shape of text available within my organization. These are all the use cases of the modern NLP. Super duper. Now let us very quickly build a classifier here. So before going to let us just take a simple example of logistic regression and try to understand what logistic regression is doing. So very importantly, any machine learning technique or even a state-of-art deep learning and all the artificial intelligence is really based on the building blocks of very straightforward and very old, I would say, a statistical model. And there is nothing new, but only there is a bit of a fancy way of doing stuff. So all the intrinsic possible ways of calculations, mathematics, and those stuff which a genius from past think we are very thankful to them that they come up with a lot of different methodologies. We are just building on those concepts, or we are just refining stuff on those concepts, although it is also very um, intellectual task to build or advance the model, but the building block, the grounds are really same, which means that if any state of art like ChatGPT is nothing but the building block is the same what we are learning right now. It is just advanced form of the basic regression or basic iteration of learning from the back propagation and derivation in the backward, or any error minimization algorithm which are seems a one liner very simple mathematical equations or the mathematical algorithms. So everything is based on that. So just right now there are too much layer of abstraction on top of them, so there are too much work has been done from the scratch and nobody cares about the fundamentals. The drawback of this thing that you sometimes don't get intuitive way what is going under the hood when you have a lot of stuff available. So you're just import char start xyz function, apply xyz, boom, and you get the result. So just applying like train.py or any simple function from the keras dot function, and there is ton of intellectual and scientific mathematical stuff is going under the hood, and sometimes you miss that, but it's okay. The thing is that sometimes you need to have trade-off between the going lower end of the code and the technology to getting more intuition, or get basic understanding what's going on and building something new on it. So there is always some trade-off. So coming back to the point, not wasting too much time, this is the logistic regression, which means, let us say that here in our case, any text ultimately also converted into the vectors of the numbers. So here we are taking simple for the sake of understanding that number of time any student studies and the outcome of the pass and fails, to predict that how many number of time you study to how much number of time you must study to pass or fail. So let's say like that this is this is the data, this is the outcome for any number of time, and you want to predict. Okay, now it's not able to put the equation right, which means that let me just copy paste in the picture way. So it's nothing but it's simply saying that what is the probability of x, which is here, what is the probability of y, what we are predicting, is equal to 1 given x. So the probability of, for example, passing given the input x. So what should be the probability? E is the simple base. Here it should be somewhere E. So this is 1 divided by E. E is the base of algorithms. And beta 0 and beta 1 are simply the actually, let me, I mean, I don't know. The equation should be y is equal to 1 given x, and it should be 1 divided by 1 plus e minus, it's e minus learning parameter beta 0 plus beta 1 plus the number itself, x, y, whatever. So when you just put your after learning, what happened here is that if any for any single iterations, model is trying to learn that what's the beta coefficient if I get this data, beta is equal to for example 0.70. Then it's try to get more data, and try to minimize the error. And now it says that whatever relationship I map between these outcome, the beta seems like 5 in the end. And after learning all those data output and the number of iteration with simple whatever error minimization technique you're using, or the derivative of the error minimization, is saying that how much I'm changing this beta, which map this relationship if I study 8 hours to the pass and study 6 hours to pass, and I study less than 2 hours to fail. So it's simply trying to learn. So for example, after the 100 iteration, it learned that the beta is actually somehow, or the coefficient or the rate of change we can say, is 0.55. And now if I want to get what is the prediction, what is the possible prediction if I study 6 hours of failing or passing. So beta 0 is something error or something which remains always same. For example, 5 is the error which could not be captured anyhow, whatever you do, and your beta coefficient which you learn actually is 0.08. So it's then very simple. If we put this whole data into this theory here, and then what is the probability of passing? Passing is the outcome y. What is the desirable outcome or desirable class? This is the class. In our case, this class would be the text belong to which category? One given x. One is the maximum probability, and x, for example, so is if I study 6 hours. Right, in this case, what I can do is that I can put this in the formula, which is 1 plus something. Okay, which in turn says that if I take the log of or the exponential negative of -5, which is the already beta plus we have learned that the rate of change between these data is 0.8 multiply by real x, which is 6. Here we multiply with the x, which is 6. So now if we calculate this, it's approximately equal to per is again okay, sorry for that. That is always return me some probability. So saying that means that if I study more than or equal to 6 hours, there is 55% chances that I'm gonna pass out. So this is the simple algorithm for that thingy, and that's how our regression works, right? This is very simple regression we are working with. Let us now get back to the code and very quickly review that code. Okay, before I jump into the code, let me just tell you that what mathematical calculation we have seen. Some libraries already have done this for models. For a lot of large model, for example, they have collected all whole amount of English text, and then they have drawn the relationship of part of speech tagging, like POS tagging. Is it is noun, pronoun, how any noun is related to the pronoun, what is the dependencies, trees of them, and what is the post of bag approach of the training, and what is the tokenizing, how they vectorize them, and then ultimately for very large models based on large of text, they train the model, and ultimately whatever we have seen like beta is now adjusting for every new iteration of data. So the weights are very similar to those, and these vector what we are importing in this code are those learned weight which we don't need to again actually do the step, because it is out of box available for us, which is thank you very much for the people who have done hard work, and they have already learned weight of the English language model, that how English language any words and sentences are related to each other and what they mean, what is the dependency cycle, and how much importance you should give to one word if one word appear after one word. So this is something we already have. Now, for example, we have this already. If we apply this on the text already, which we got here, then we have rather than a raw vector. So, for example, in our case, what we have studied, number of times studies we have seen, so those number we have get the more trained number, more meaningful number. And when we apply the logistic regression on that, then we gonna get more fancy or more good results on more good result. So this is simple initialization, nothing fancy here. We are simply loading the CSV file, which is the combination of the file we were getting, and then simply there is one function which does nothing but which import the scikit-learn sklearn scikit-learn, which gives you a lot of stuff like it's just split the data in train, test, and evaluation. So you must have a clear difference between the trained data and test data and validation data. The simple step is that the validation and test, the difference between these two is that during the training process, the validation data is available to model sees it based on some data which never exposed or available to the model, and model sees how I'm performing, and based on that it's try to readjust some intrinsic parameter automatically to reach out on the more accurate model. This is what validation is, which means that validation data is available to model during the training so that it can learn from it and readjust. For example, at point epoch number or iteration number 10, the validation data available is 60%. It has done, and on iteration 100, it has seen all the validation instance or picture or whatever you're training. But the test data is something available after training is done. For example, you're done with training and then you apply and see that after everything, how the final results look like in working. So this is the basic difference in the validation. A lot of concept in between, but sorry for that. So yeah, so for example, so we are just splitting it, nothing fancy. And here actually we vectorize what I have um, talked about recently, that we are loading a model, which is this is score, which we loaded in our local memory, which is nothing but a complete vector. We somehow need to apply this. So what we are doing here is that we are splitting the data, and then we are with help of this NLP, we are aggregating the vector, which means that we are converting the vector. And now we will apply the weight on these vectors later on. And now prepare the data. We are getting the document vector for whole text, which means that we are creating a new column, means doc vector. On the pre-processed text we have it, and we apply the vector which can convert the text into numbers, nothing fancy. So on whole data it's doing the same stuff, it's converting over text into numbers, that's all. So after preparing it, the data should be in matrix form, or let's say like that numpy uh, x dimension matrix, or simple list, which means that it should be consumable in the numpy fashion. And that's why we need to convert it from the pandas data frame to the list. Simple stuff here, just shifting this to list, and then it's give us x test and x like for training data. Great. And then we train the model. So here you see whatever I have talked earlier, that nowadays training is nothing but lr.fit, logistic relation.fit. You give the model the data and it's doing this stuff behind the scene. And this is scikit-learn again, and we have import logistic regression written in that. We don't need to map this whole equation what we have studied, it's already done there, it's available as a given to you. Create, and then you evaluate the model. For example, you supply some test result here, and you see how it's performing, and then you're able to calculate how it's deviate from y test to y predict, and precision score in the end. So then we have also done here topic modeling. For example, you can within the text categorization, you can for example, you have categorized your article as a sport, and now within the sport you can also tell that which topic it's talking about. It's talking about tennis, cricket, which sports is talking about, or more and more topic modeling. And you can do this here with this text. We pre-process it and we apply some topics on it, right? So let's see in the Python notebook that what we have done after that. Here is the thing. We were able to get data in this shape, and then training, classification, and evaluation data happens. We have import in similar fashion our classifier, this class here, NLP, from the same folder. We import this on top, right? And we import this here, classifier, from our file, and then we load data. We call the function method. Function or method is same meaning. And when we load the data is looking like that. Then we split the data, and now we can see that how much 418 is our test data, and 105 is train data, and 105 is test data. Simple stuff. Cool. Then actually we apply another stuff here, classifies, prepare data, which is converted into the vectors anyhow, and then we just train the model, which is doing nothing. Then we evaluate the model, and in the end it's running for a couple of minutes, right? And after a couple of minutes, this gives us 97% accuracy, which is very, very great for the logistic model. And which means that if we build this model, we train this model in this way, for any English text article, we were able to categorize it and label it. We don't need any human being for that. That's the practical use case. And now if we perform the model here, it's actually tell you that what topics are discussed here. There's some years, what country it mentions, right? What entity it's mentioned, what country is mentioned, what army is mentioned. So name entity recognition is very important for further analysis, and yeah, that's the end of the stuff, and that's how the practical use case works. And that's how actually a barebone NLP works at the medium level. If you can go to the more downward in the pipeline, so there are a lot of things involved. A lot of things involved means that you refine the text, you how the methods and techniques used from the raw text until you get the vector of text. There are a lot of NLP involved, but nobody cares right now nowadays, because this is already done for most of the languages, even like more than 200 languages or 180 languages. Already everything is done. You don't have to reinvent the wheel. If you want to do something, do with deep learning, with transformer, come up with architecture, stuff like that. Thank you very much for watching. Yeah, that's all. This is the end of the video, and stay tuned. Bye.